Welcome to the solutions for the Regents Kinematics problem set numbers 10 and 11. Let's take a look here at number 10. What does the slope of the tangent to the curve on a distance versus time graph measure? What does the slope of the tangent to the curve represent on a distance versus time graph? Well, by now you're familiar with the fact that slope of a best fit straight line on a distance time graph is the average velocity. But what if we had a graph like this where it was very obvious by the data that the distance was increasing with equal increments of time and the rate at which it was increasing seemed to be constant? Well, what this would indicate to us is that the object is accelerating and not moving with some average velocity, not trying to maintain the same speed. Yet in this graph, it would mean that the object was getting faster and faster and faster. It would then be in the best interest, the best fit to this data would not be a straight line, but rather a curve. A curve, by the way, that's quantified by a quadratic fit, as you see on this graph here. Okay, and we'll talk about later on why the quadratic fit is the appropriate choice there. No longer would we be able to ask the question, what's the average velocity during this time interval, though we could answer that question and just by doing that. But what if we instead wanted to know how fast is it going at an instant in time? And we would call that the object's instantaneous velocity. Well, velocity on a distance time graph is still going to be the slope. The y units are meters, the x units are second, so dividing y by x would be meters per second. So slope is still the answer here, but it's not the slope of all our data over a time interval, but rather it's the slope at a particular given time. So I'm going to do this example with you here. We're not going to do it numerically, but just qualitatively here. What if we wanted to know how fast the object in this particular graph was going at 2 seconds? How fast the object traveling at time 2 seconds? What we would do is we would draw a tangent line to the graph at 2 seconds. And remember that a tangent line only touches the curve at that spot. So we'll demonstrate that here. I'm going to start with just a line, and then I'll make it a tangent line here in a second. I'm going to change its color to make that stand out a little bit. Okay, and then we'll go back over here and make this a tangent line at 2 seconds. So it's just touching the curve at that spot. And that would be a good tangent line. A decent tangent line at 2 seconds. Now what you would do is you would take this tangent line and you would find 2 spots that intersect the grid pattern on your graph paper. Okay, and mine's a little fuzzy here, but I'll try to locate. It looks like maybe there's one right here, and as I go down maybe towards the bottom a little bit, okay, it looks like maybe right here would be a spot. And if it's not, it doesn't matter. It's just for illustrating purpose here. So if we follow this down to here and follow this across to here, what we get is a way to calculate the change in y and the change in x for this tangent line. And by calculating that slope, so our slope would be delta y over delta x, that would give us the instantaneous velocity at that spot, at that time. Okay, so that's how, for example, we would calculate the instantaneous velocity at 2 seconds, how fast the object is traveling at exactly 2 seconds. So what does the slope of the tangent to the curve on a distance versus time graph measure? It measures the instantaneous velocity of the object. By the way, you can tell also by adjusting the tangent line along the curve, that you can see your tangent line would get steeper and steeper and steeper as time goes on. And since that's instantaneous velocity, that tells you it's getting faster, which indicates that it's accelerating. So nice little tie in there. All right, let's take a look at number 11. If an object's velocity time graph is a straight line parallel to the time axis, what can you conclude about the object's acceleration? Clearly, you see a shift in this set of problems, that it goes from distance time graphs to velocity time graphs. And we have to change our thinking a little bit when we do that. So let's start by just sketching out. And we're just going to sketch this one by hand. Okay, and we'll put the velocity in meters per second on the y-axis, and our time in seconds will go on the x-axis. And let's just, this would be, of course, a velocity of 0. We'll mark off a few increments here: +1, +2, +3. We can also have negative velocity, -1, -2, -3. Okay. And so the question says, all right, so we've got a little velocity time graph here. Mark off equal increments of time if we want to. 1, 2, 3, and so on. Seconds all the way up through there. Okay. So the question asks if the object's velocity time graph is a straight line parallel to the time axis. So it could be a velocity there, or it could be a velocity down here. Okay. What can you conclude about the object's acceleration? Well, the acceleration on a velocity time graph would be the slope of the line on that graph. Just like velocity is the slope on a distance time graph, acceleration is the slope on a velocity time graph. Well, you can clearly see, what's the slope of a horizontal line? Well, the slope of a horizontal line is 0. Therefore, what does that indicate? What can you conclude about the object's acceleration is that it's not accelerating, that its acceleration is 0. One little other note here that I want to make, as long as we're here with this velocity time graph business, is that you can also tell something about the object given its line, whether or not the line is above the time axis or the line is below the time axis. So the other possible lines that we could see on this velocity time graph, or any velocity time graph, would be a positively sloped line. We could see a negatively sloped line above the time axis. We could see a negatively sloped line below the time axis. We could see a positively sloped line below the time axis. And of course, this indicates to us different kinds of motion. But the key is that for all these lines that are above the time axis, this means that the object is traveling away from the point of origin. And for all objects who create a line below the time axis on a velocity time graph, this means the object is moving toward the origin as far as its motion is concerned. Alrighty, just some extra little learning on there. I'll look to see that in your notes tomorrow when we get in class, and we'll also be finishing 12 and 13.